Hello students, my name is Emma Reed. I'm an 8th grade math teacher, and today we're going to be talking about how to represent large numbers on the number line. So today's introduction/launch section on slide A starts off with some information for us about speeds of light. So read along with me while I read that first part out loud. As light moves through different materials, it slows down. The speed of light through empty space, with nothing in its way, is roughly 300 million meters per second. The speed of light through olive oil, while still quite fast, is much slower at roughly 200 million meters per second. So that's a lot of information, and we haven't even gotten out of our box at the top with the context. So what I think when I run into a problem that's this wordy is that I should use the 3 reads to help me. So the first read is, what is this question about? Or what is this problem about? So take a moment and think about, what is this problem talking about? What do we know just based on the first part? And once you've had some time to think, pause if you need to. But once you've had some time to think, we'll read the bullets at the bottom because that's also important information for us to have. So then we see it says, decide what power of 10 to use for the label of the rightmost tick mark on the number line so that the speed of light through space and through olive oil can be plotted. Plot the speed of light through space and the speed of light through olive oil in the appropriate place on the number line. So this is where we're thinking in general about the problem. What is this about? What story is this telling me? And for the first read, you don't want to focus on the specific numbers. You want to focus on what the numbers are doing. So those numbers that you see in problems, they're quantities. Sometimes a quantity is measuring an amount or a distance or a rate. And sometimes a quantity is showing you more about a relationship. So it's not measuring or counting something, but maybe it's telling you that something is twice as fast as something else, or an amount is 10 times greater. So when you read and you ask yourself what the problem's about, you want to think, what is the story? What are the quantities or relationships in this problem? So think about those things about this specific problem to yourself. And then we're going to read it again. And this time we're going to ask ourselves, what is the question asking? So this time I'll have you read this on your own, read the problem again. Ask yourself, what is this question asking? You probably want to pause the video so you have enough time. And when you're done rereading and you have an idea of what the question is asking, you're going to use the question to help you decide what information is important. So on your third read, when you read the problem again, you're looking for important information, and what's important to you is going to depend on what the question is asking. So we could ask a different question, and different information from the problem might be more or less relevant depending on the question. So based on this question, read it again. What information is important for us to know? Okay, so if you've had time to do all 3 of your reads, to ask yourself, what is this about? What is the question asking? And what information is important? Then and only then are you prepared to start answering a question. And if this feels like too much to you, too much work to read the problem 3 times, just trust me that it is going to save you time in the long run to fully understand what the information is telling you and what information you need before you start to solve. Because it'll save you all that time you would have to spend redoing your work if you didn't fully understand what the question or the problem was really telling you. So at this point, pause the video, finish your answer on this slide, and then we're going to move into our Explore section. Okay, so our Explore section is building on our launch, and we're still thinking about the same context of different speeds of light. So our Explore section tells us the number line below shows values from 0 to 1 times 10 to the 9th power. For this activity, we will need to zoom in to highlight the values between 2 times 10 to the 8th power and 3 times 10 to the 8th power. Go on to slide C to label the tick marks. So before we move forward, take a moment and connect what you're reading on slide B to what we read on slide A. Ask yourself, where did that 1 times 10 to the 9th come from? Does it match what I was thinking on slide A? Where did those numbers 2 times 10 to the 8th and 3 times 10 to the 8th come from in the previous slide? Make those connections, and then we'll look at how we can zoom in on the number line on slide C. So here you can see we're zoomed all the way in on the original number line that we created, and we're going between 2 times 10 to the 8th power and 3 times 10 to the 8th power, and we're thinking about what would these little increments or little spaces be if we zoomed in on this number line. So take a moment, look at the coefficients you're given, look at the bases, look at the exponents, and think about what each step should be. Now that you've had some time to fill in your number line, we're going to finish off our Explore section on slide D. We're still thinking about this idea of other speeds of light, and the table shows how fast light waves can travel through different materials. So you can see we have the speed through space, water, diamond, ice, and olive oil. You're going to plot and label a point for each speed on the number line. So you're going to use those benchmarks on the tick marks to decide where each speed belongs. And finally, you're going to describe which speed cannot be plotted on the number line, which is it, and why can't you plot it here. So you'll definitely want to spend some time here thinking this through and plotting your numbers. You can pause, and when you're ready to sum everything up, move on with me to the next slide. So finally, for your summarize section on slide E, you're going to answer our big question, how can we compare large numbers using powers of 10? Bring together everything you thought about today, and make sure you're talking about what you learned from these experiences in your summary. Thank you for joining me today.